Good day everyone. Today I will be reporting about relationship and function as essential topic both mathematics and computer science. This includes understanding binary relations, equivalence relations, function and how we combine or reverse. Function through composition, an inverse operation. Understanding this concept give us the foundation to model analysis and solve problems involving set-up mappings. Part 1. Binary relation. Let's start with binary relation. A binary relation between two sets A and B is simply a set of order pairs AB where an A belongs A and B belongs to B. If both elements are from the same set A, we call it relation on A. Now, there are three important properties of binary relation on set. The first is reflexive. A relation is reflexive if every element related to itself. Example, in a set of A, 1, 2, 3, our reflexive relation must include 1, 2, 2, 1, and 3, 3. Symmetric naman is symmetric. A relation is symmetric if every AB in R, BA is also in R. Example, if 1, 2 in R, then 2, 1 is must also be in R. In 3, transitive. A relation is transitive if whenever AB and BC are in R, then AC must also be in R. Example, if 1, 2 and 2, 3 are in R, then 1, 3 should be in R. Let's take quick example. Let A equals 1, 2, 3 and let R 1, 2, 2, 3, 2, 2, 3, 3, 1, 2, 2, 1. This relation is reflexive and symmetric but not necessarily transitive unless we add 1, 2, 2, 2, 2 and 1, 1. Etek. Part 2. Equivalence, relation, and participation. Now, when R is reflexive, symmetric, and transitive. All three, then we call it equivalence relation. This relation help us grow or classify elements that are equivalent in some way. Example, let A 1, 2, 3, 4, 5 and equivalence relation could be R equals to 1, 1, 2, 2, 3, 3, 4, 4. This just relates each element to itself. From on equivalence relation, we can recreate participation of the set. A participation is a way of dividing the set into non-overlapping, non-empty subset, where every elements belong to exact one subset. In simpler terms, partitions are groups equivalence element based on relation. Part 3 is function, injective, subjective, bijective. And now let's move on to function. A function is a special kind of relation. Each input from the domain is related to exact one output in the code domain. There are three important types of function based on how the elements map. One is injective, one-to-one. Every output is mapped at most input. Example, xr equals to x2 is injective because different x values give different y values. Number 2 naman is subjective. Onto every element in the code domain has at least one input mapping to it. The function covers the entire code domain. Number 3 naman is bijective, one-to-one compromise. A function bijective if it both injective and subjective. That means every element in the code domain is mapped once and all by an input. Example, function f is r equals to r defined by f x equals to 2x. This function is injective. No two x value give the same output. It's also subjective. Every real number can be written as 2x from some x, so it's bijective. Composition of functions. We can combine two functions using composition. This is written as f compose g x equals f g is x. It means we first apply g x, then apply fx to the result. Example, left x is equal to 2x and g x equal to x plus 1. Then f compose g x equals f compose g x equals f x plus 1 equals 2x plus 1 equals 2x2 plus. Inverse function. If a function is bijective, we can define its inverse, written as f inverse negative 1x. The inverse reversed the effect of the function. For example, if f equals x 2x, then f inverse 1 negative 1 x equals to x 2, because if f inverse 1 x equals to 2 times x 2 equals x, f inverse 1 fx equals to 2x 2 equals x. Inverse functions are essential in algebra, synchrotopography, and many real-world applications. Conclusion. To wrap up, binary relation help us understand how elements from one or more sets are related. Equivalence relation classified elements into groups with shared properties lead to partition. Functions are special relation that map each input to exact one output, and they can be injective, surjective, or bijective. Using composition, we can combine function, and if a function is bijective, we can find its inverse. These concepts are not only foundational in math but are also widely used in computer science, logic, data modeling, and more. Thank you for listening.